All right, let's talk about AI. We're going to trace its whole unbelievable story, starting from this, wildly ambitious dream all the way to the tech that's literally in our phones and our cars right now. So let's just dive right in. It all boils down to this one question. Can a machine really think? I mean, really. It sounds so simple, but this question, it's the heart of everything. Can a machine truly have intelligence? Can it learn? Can it think the way a person does? This is way more than just a tech problem, right? It's this huge philosophical quest that has been driving the whole field for decades. So let's go back. Picture the 1950s. There's this incredible sense of optimism in the air right after the war. And you have this small group of just brilliant minds who get together, and they are absolutely convinced they are on the brink of creating something that would change the world. A machine that could think. And this right here, this quote, was basically their mission statement. The confidence is just breathtaking, isn't it? They're basically saying, hey, intelligence isn't some kind of magic. They believed it's just a process, something you can describe, something you can break down, understand, and, here's the kicker, actually build into a machine. And this is the moment it gets its name. Summer of '56. A workshop at Dartmouth College. You've got guys like John McCarthy, Marvin Minsky, all the big names, and they come up with this term, artificial intelligence. They set these incredibly bold goals that would set the course for the next 50 years. The quest was officially on. But, like any epic story, the path forward wasn't exactly a straight line. Not at all. That initial explosion of excitement, it pretty quickly turned into this dramatic roller coaster ride of amazing breakthroughs, followed by just crushing disappointments. Hype, hope, and then heartbreak. So what was fueling all that early hope? Stuff like this. Back in 1952, a guy named Arthur Samuel made a checkers program that did something just mind-blowing. It learned. It literally played against itself over and over and over, and it got so good that it could beat its own creator. I mean, think about that. This was a huge deal because it proved a computer could do more than just what it was told. It could actually get better all by itself. Okay, so you have that success, and then bam, a huge reality check. Researchers thought, hey, machine translation should be easy. We just swap words from one language to another. The results? They were hilarious. This famous example, it just perfectly shows that language is so much more than words. It's about nuance, it's about context, and that turned out to be a way harder problem than anyone dreamed of. And all those failures, they led to what's known as the first AI winter. All the big promises just couldn't be kept. I mean, the computers back then were just painfully slow, right? There was nowhere near enough data to learn from, and maybe most importantly, the machines had zero common sense. So, surprise, surprise, the funding completely dried up. The dream pretty much went into hibernation. But this whole period forced a really important change in thinking. The new idea was, okay, maybe we can't make an AI that thinks about everything, but what if we could make one that's an expert in just one specific thing? And that's exactly what they did. To get out of that AI winter, they completely switched gears. Forget about building a machine that thinks about everything. The new, much more practical goal, let's build a machine that's an expert in just one thing. So this new thing was called an expert system. And the idea behind it is actually pretty simple. Think of it like a massive digital flowchart built from an expert's brain. It's all based on a bunch of if-then rules. If the patient has these symptoms, then the diagnosis is probably this. It was a super practical, really powerful approach, and it's what brought AI back from the dead. So let's look at a great example, a system called Mycin. This thing was basically a digital specialist for blood infections. It was packed with hundreds of rules from top medical experts. So a doctor could feed it a patient's info, and boom, Mycin would spit out a likely diagnosis and even recommend antibiotics. Sometimes it was even more accurate than junior doctors. This was real, tangible proof that this new focus strategy was actually working. And it wasn't just in medicine either. There was another program, Dendrol, that was basically a master chemist. You could feed it raw data from a spectrometer, and it could figure out the molecular structure of a chemical. I mean, this is a super complex job that usually takes a human years of training to do. And here's where it really hits the bottom line. A system called XCon. Its job was to figure out all the right computer components for customer orders. This was a hugely complex puzzle, and XCon nailed it every single time. It ended up saving its company a fortune, literally millions of dollars. So now, AI wasn't just some cool project in a university lab. It was a real commercial success. Okay, so expert systems are having their moment. They're a huge success. But at the same time, there was this other idea, an older one that was kind of sitting on the sidelines, just waiting for its big comeback. And this idea wasn't about if-then rules. No, this one was inspired by the most complex thing we know of, the human brain. And the story of these neural networks is a wild ride all on its own. The basic concept pops up way back in 1943. But then, in '69, a book comes out that just demolishes the idea, pointing out all its flaws, and it pretty much kills the research for years. Then, a huge breakthrough in 1986 called backpropagation, which is just a fancy way of saying the network could learn from its mistakes, brought it back to life. But the real revolution, the Big Bang, happened around 2012. And that was because of a perfect storm. Suddenly, we had big data, just mountains of information, and the super powerful computers you needed to actually process it all. And that brings us right up to the present day. When you hear about AI now, the stuff that recognizes faces in your photos, that translates languages on the fly, that creates incredible art, you're talking about these complex, multi-layered neural networks. They are the direct descendants of that little idea that first sparked way back in 1943. Okay, so we've got these different threads, right? We've got rule-based expert systems, we've got brain-inspired neural networks. How does it all fit together today? Well, the modern way to think about AI is through this core concept, the intelligent agent. And what is an agent? It's actually a really simple idea. An agent is just anything that can sense what's going on around it and then do something about it. Think about it. For you and me, our sensors are our eyes, ears, and touch. Our actuators, the things we use to act, are our hands, our feet, our voice. For a self-driving car, the sensors are cameras and GPS, and the actuators are the steering wheel and the brakes. See? It's that simple. Sense, then act. And when engineers design an AI, they often use this handy little framework called PEAS. It stands for Performance, Environment, Actuators, and Sensors. So if you're building an AI taxi driver, you start with P, Performance. What does a good job look like? A safe, fast, comfortable trip. Then E, Environment. Where does it operate? On roads, with traffic, pedestrians. A is for actuators. What can it do? Steer, accelerate, brake. And S is for sensors. How does it see the world? With cameras, GPS, sonar? It's a really smart, structured way to design something so incredibly complex. And you can see how the difficulty of building an agent really depends on the world it lives in. An AI that plays chess, its world is a piece of cake, relatively speaking. It can see the whole board, the rules don't change, and it knows exactly what the opponent can do. But a self-driving car? Oh man. Its world is messy. It can't see around corners. The world is constantly changing. It's unpredictable. And it's full of other unpredictable agents. Us. So that's really the whole journey in a nutshell. The big goal of AI has kind of shifted over the decades. It started with this grand philosophical quest to build a machine that could think like a human. And it's slowly but surely evolved into something more practical, the science of creating rational action. It's about building these agents that can operate effectively, that can see, reason, and act to get things done in our very complex, very messy world. Which brings us to a really interesting final thought. We've gotten really, really good at building machines that act rationally. But does that mean we've given up on the original dream? Is a truly thinking machine, a conscious machine, still the goal? Or is that a mountain we'll never climb? That's what's so cool about this whole field. The story is nowhere near finished.